Very good morning, students. Welcome back to second year physics. See, actually in the previous class, so we completed one chapter. The chapter is related to the field under charge. Of course, we know field under charge. So we finished about a field under charge. In that field under charge, see, in general, these chapters are related to like electrostatics. I told you very clear in the previous classes also. Static means rest, so that the rest can create. Of course, once again I will explain you. Rest can create. Very simple. See, rest charge can create both force, field, and next one is potential. Right? So of course in the previous chapter, so that we completed a force and field also completed. Let us now we look into potential and as well as the capacitance. So the potential, sir, what is mean by potential? Of course you remember potential is a scalar. This is the first point. And coming to the point is, in case of a electrical potential, sir, what is mean by potential? See, the electrical potential is nothing but it gives the electrical state of a charged body. That mean here, suppose let you take the two charged bodies are connected. See, electric potential is gives the electrical state of a charged body. That means electrical state of a charged body in the sense is that says about the charge. Suppose I'll tell you, let you take a one charged body which is positive, right? And it is connected by one conductor like this, and it is another charged body, we can say negatively charged body. One we can say positively charged body, one more we can say negatively charged body, which are connected like this. Clear? Now coming to the point is, in this case, this potential is gives the electrical state of a charged body. What is mean electrical state of a charged body? Here the positively charged body is nothing but we can call as the higher potential. Simple. You say here higher potential it is. Right? And here low negatively charged body is nothing but we can say like a lower potential. So that here thing is potentials are represented like this. And here coming to the point is, there is a direction of current is. So the direction of current is, it is represented, or the always the direction of current is along a positive charge. Along a positive charge. Direction of current. You say direction of current is always in the direction of positive charges. Or we can also say opposite to the negative charges. Opposite to the negative charges. That is the direction of current is gives the potential only. That mean here current direction is always from higher potential to lower potential only. That is we can call conventional current direction. The direction of current is along a positive charges or opposite to the negative charges. And you remember one more point I would like to tell you. We know about a gravitational potential, right? Because already we discussed in the first year in gravitation. So the gravitational potential also scalar. Of course, electrical potential also scalar. You remember wherever the potential, that potential is all related to what? It is a scalar. Magnetic potential, of course, it is also scalar. So that's what here gravitational potential of a body. You take a earth. Earth is a huge body. Moon is a huge body. Of course, due to a earth or moon at an infinite, due to that body at an infinite is, you say, 0. The potential at an infinite is 0 due to a bodies, because till infinite it will not act. Till infinite it will not act due to a that body. In case of a gravitational potential, in same manner, in a same situation, here in a charge also same. Due to this positive charge, the potential will be at an infinite is 0. And due to this charged body and at an infinite is potential is 0. That's what mean here. So that at an infinite is due to a charged body's electrical potential is 0, because till that point it will not act. Certain distances it is act. That's what. Here it is a very, very important. Not only potential, you say in charge, due to a charge, field also it will not act. Like force also it will not act till what? Till a like infinite like that. Right? So that's about what it is like a potential. Sir, what is actually mean by potential? Yeah. Coming to the point is, we'll move to the potential. See, I would like to tell you, first of all, electric potential statement, and we'll look into that. See, electric potential, you say V. Here, coming to the point is, see, I'll tell you the statement. Let us coming to the point is, see, due to a one charge, see, you take a one positive charge, right, which is placed at a point. Therefore, this point charge, due to a point charge, the field will act certain positions due to this charge, due to this positive charge at a point O. Therefore, this field is act till a point, some distance only. This is the field is acting. Field is acting certain distances, certain points only. So that it is acted till a distance, you say some distance. Now let us you say another unit positive charge. Of course, here is a placed at a O also positive charge. Due to that positive charge, the field is acting certain distance, certain place, certain through a distance. Then let us you take another unit positive charge. Another unit positive charge. You say unit positive charge it is. Q naught you say, or we can also say test charge. So that which is bringing from, right? So which is bringing from infinite. You say this charge is at an infinite. Now this charge is bringing from infinite, and it is bringing from infinite like this. Say, look at. Say, when it is bringing from infinite, is there an opposition? There is no opposition. Very simple. So the charge is Q naught is bringing from infinite, and there is no opposition. So that when there is no opposition, there is no work is said to be done by the bringing of this charge. Because here there is no opposition. If there is no opposition, we can say there is work is there is no work is said to be done by this charge. Now it is bringing from infinite, and which is placed at a point, some A point. Due to this charge, the field is acting till a point A, you say. Now this charge is placed at a point Q naught, I mean at a point A. Which charge it is? A test charge. Test charge which is bringing from infinite, and it is placed at a point A. It is placed at a point A. Therefore, there is an opposition due to this positive charge. There is an opposition because due to this positive charge, the field is acting till a point A. After that, there is no field due to this charge. Suppose you assume like that. So that another positive charge Q naught is bringing from infinite. Therefore, that Q naught is bringing, and which is placed at a point A. Of course, there is an opposition because it is also positive and it is also positive. So that there is an opposition. Now you say there is a work is said to be done because opposition is there, no? When there is an opposition, therefore there is a work is said to be done by the bringing of unit positive charge. Work done by the bringing of unit of positive charge from infinite, and it is placed at a point in the field given by the another charge. Field given by the another charge. Very simple. Very simple, because this charge is given, this charge is placed at a point, and this field is acting till a point A. And now we are bringing another charge, from infinite, and which is placed at a point in the field given by this charge. Of course, there is an opposition because both are the positive. Therefore, there is a work is said to be done by the bringing of unit positive charge from infinite, and it is placed at a point. Therefore, you say work done is directly proportional to Q naught. Because now it is entering into the field, no? Therefore, there is a more opposition will get. So that if I move from A to some B, there it is a more opposition, because positive always repel. Then you say W is directly proportional to Q naught. Therefore, W is equal to some constant is introduced, that we can say electric potential. Then V is equal to W by Q naught. This is the electric potential. It is, we can call as the electric potential, static electric potential. So that V is nothing but a potential, and it is defined as work done, see, per bringing of unit of positive charge. So the potential is defined as it is defined as, so like we can say the work done per unit of positive test charge. Work done per unit of positive test charge is Q naught is bringing from infinite, and which is placed at a point in the field. which is placed at a point in the field is nothing but we can call as the electric potential. We can call as the electric potential. So that V is equal to W by Q naught. This is about electric potential we can say. So that here W by Q naught. Here of course we should say units and dimensions as usual. So that here you say unit is in general we can say like a SI system, that is we can say joule per coulomb. Joule per coulomb we can also call as a volt, right? Therefore 1 volt is defined as 1 joule by 1 coulomb. That means here 1 coulomb of charge is bringing 1 coulomb of charge is bringing from infinite. Therefore there is a 1 joule of work is said to be done, which we can call as a 1 volt. So the 1 volt is defined as 1 joule of work is said to be done. We can also define like this: 1 joule of work is said to be done by the bringing of 1 coulomb is nothing but we can call as the 1 volt. Or it is a 1 coulomb of charge is bringing from infinite and there is a work is said to be done by the 1 joule. So which we can call as the 1 volt. So like this it is a volt statement and it is a we can say electric potential. Now coming to the dimensional formula, which is important here, right? So right here work done we know ml square t power minus 2 and here q naught is nothing but a charge I into t. Therefore ml square t power minus 3 I power minus 1. It is the dimensional formula for electric potential. And here of course I told you here at an infinite due to this charge, at an infinite due to this charge, due to this q plus q charge, is there any potential? No. Remember, that's what here. So coming to the point is there will be a, because of the charge bringing from infinite, we can also say work is said to be done. The work done which is in the form of a potential energy. Yes, we can say potential energy. So that at an infinite potential energy you say U infinite and at this point you say UA. It is a potential energies U not V. So that at an infinite potential energy you say U infinite and at a point A you say potential energy is UA. So there is a difference in potential energy. Of course, we can also say from this expression V is equal to delta U by Q naught. Yes, of course, because work done which is in the form of potential energy, Here it is the initial point, this you say initial point and this is you say initial and it is a final. So always changes we can say potential is equal to, it is a final minus initial. So UA, it's U not like V, right? UA minus U infinite by Q naught. This is, we can also say in terms of potential energy, that's what I mean to say. UP is nothing or UA is nothing but a potential energy at a point A and U infinite is nothing but a potential at an infinite. And one more again I am repeating you, due to this charge potential at an infinite is 0, very very important. That's what gravitational also we can say like that only, gravitational field also we can say like that only, right? Clear? And it is about a these are the things related to the electric potential. Clear? And here you remember this is the dimensional formulas and units and as well as the V. Again dimensional formulas and V are very very important, right? And in the same manner we have to say about a potential difference. Sir, what is potential difference? Of course, the difference between the 2 points. It is everything is same. Difference between the 2 points. Suppose the charge is bringing from infinite and it is placed at a point A. Now from point A to again it is moved into into the field. There is a more opposition. Now the charge is moved from point A to point B. Suppose you say the charge is moved from A to B. That is, it is moved through A. Suppose you say between these two charges is X. And it is moved from A to B, there is a small distance is moved from A to B opposite to the field due to field by Q. So that it is moved from A to B, there is a more opposition and there is a difference is there between these 2 points. Because at this point you say the potential from infinite we can say VA and at this point the potential we can say from B point, you say B point we can say it is VB. These are the potential differences. So between these 2 points, the difference is nothing but again the work done per unit positive test charge, work done per unit of positive test charge, everything is same. Everything is same, but we can say difference between the 2 points. Here the difference is there, no? At this point the potential is VA from infinite, and here at this point is VB from infinite, because there is a difference is there. Suppose if I take another point, of course it is also difference. So that the electrical potential also defined as same, it is no doubt, it is the, we can say the work done per unit of positive test charge. Work done per unit of positive test charge, which is bringing from infinite, and it is placed at a point in the field. Therefore, there is I mean to say against the electrical field intensity between the 2 points. Difference, just we are saying about a difference. Suppose I would like to, units and everything is same. Potential difference also, units and dimensional formulas, everything is same. Just you represent like this. See, it is also same. It is the initial position and it is the final position, right? So that we can say potential difference between the 2 points, that is A to B. You want to say about A to B, or you want to say another points, if it is given, then you say A to B. A to B. There is a difference between the initial and final, right? Initial and final. So that we can say final minus initial, we can say final minus initial, VB minus VA it is. Just to replace like this. Therefore, here we can write VAB is equal to VB minus VC is equal to work done per unit of positive test charge. If we are moving opposite to the field intensity, suppose if I moved along the same direction, the charge is moving along the same direction, is there an opposition? No. So that is there any work done? No. Simple. So that here, if it is moved from A to B against the field, there it is to be work is said to be done. If I moved along the same direction, the charge is, this Q0 charge is moved along the same direction, there will not be work done. The work done is 0, because that is work done by the charges, it is 0, because there is no opposition. No? There is no opposition, and you remember here the potential is more here than this A point. That's what we can also say like this, VB is greater than, yes, VB is greater than VC. That's what we are writing, VB minus VC, because there is an A potential is more here than this point. That's what you write here, VB minus VA, final minus initial. So that here VB minus, I mean to say VB minus VA it is, A point, no? So that here we can say VA, B is nothing but we can say final minus initial. Units and dimensions are everything is same. Clear? That is, the units are nothing but a volt, potential difference is measured in volt, or it is a joule per coulomb we can call. Clear? This is the information related to the electrical potential statement and difference. And one more point I will tell you, suppose if a positive charge is there, sir, what will happen due to a positive charge? Of course, positive charge will give the potential is positive, electric potential is positive due to a positive charge. So the positive charges gives the positive potential, you say positive potential it is, right? And if negative charge is there, therefore this due to negative charge, it gives a negative potential. So these are the information related to the electric potential. I think everyone is clear, right? I think there is no doubt. There is no doubt. And yet there is one more question is there for IPE point of view, 2 marks. In general, already in the previous chapter also I told you very clear. Earth is considered as a zero potential. Sir, why Earth is considered as a zero potential? Why not we can consider as a positive? Why not we can consider as a negative? See, Earth is a huge reserve of a charge. Same I told you very clear in the last chapter. You take a Earth. Actually, Earth is a neutral body, right? Neutral in the sense is positives and negatives are equally distributed. That right? I think you know this, right? Like Earth it is. So Earth is a huge reserve of a charge. See, by adding a charge or by removing a charge, Earth potential does not changes. Suppose we are adding some charges or we are removing charges from the Earth, so that there will not be changes any state. So that the state remains the same. That's what we can call Earth is considered as a zero potential. V is the potential, not velocity. You come out from that, right? So V is nothing but a potential it is, because we are discussing in electricity, not in straight line, not in motion in a plane. So in that motion in a plane, straight line, we can say V is the velocity. But here we are saying what? We are discussing about related to the electric current, no? Or electrical potential. Potential is the V. Now coming to the point is, sir, earth is considered as a zero potential, no? Then I'll tell you one example. Suppose you want to measure the potential of a one body, so that the body should be connected to the earth only. The reference we can take as the earth only. That's what buildings, while constructing the big buildings or while constructing the big whatever it is, towers like that, so that they are connecting the earthing they are giving. Why earthing giving? Because earth is considered, it is a zero potential. Sometimes we may get the more charges, therefore the charges is flows into the earth, so that it is neutralizes. If sometimes we may get a less charges, so that the earth is gives the charges to that body. So to make the potential is constant. So that I'll tell you, suppose I want to connect a one positively charged body. So you take a one positively charged body to measure the potential of a given body, so that it is connected to the earth. Say symbol of earth is, we can say like this, it is a symbol. So that for positive charge, positive is nothing but there is a deficiency of electrons. So that we can say when it is connected like this, therefore earth becomes like a negatively charged because of positively connected, no? Now earth becomes like a negative charge. Negatively charged body is nothing but we can call, there it is to be excess of electrons. So that excess of electrons flows from earth to the body, and the direction of current is from positively charged body to negatively charged body. Sir, the charges flows until what time? Of course, till the body is, this body is neutral, till that the flow of electrons from the earth to the body flows. So now what we are doing here, we are removing some charges. So when we are removing the charges, there is no change of state of earth. The state will be same. That's what electrical potential is zero. Earth is considered as zero potential. It is for 4 marks, or sometimes he may ask you 2 marks. And suppose you take a negatively charged body is connected. Negatively charged body is connected to the earth, so that earth becomes like a positive. So earth becomes like a positive in the senses what we can say. Therefore, there is a deficiency of electrons for the earth. So when there is a deficiency, therefore electron flow from earth, the body to the earth. Sir, until what time that flow of charges takes place? Of course, till the body is neutral. So now we are adding the electrons to the earth. Now here it is we are removing, here it is adding. So when removing, adding, there is no change of state. There is no change of state of earth. So when there is no change, therefore we can say earth is considered as a zero potential. Explain. Yes, you can explain like this. While adding or removing the charges from the earth, so that there will not be changes the potential of the earth. There will be not changes the earth potential. That's what we can say, earth is considered as a zero potential. So that if any object or any body you want to measure the potential, so that we can take the reference to the earth, or we should connect to the earth only. So by connecting the earth, we can measure the potential of the given body. So that it is for 4 marks question, which is very, very important. You can explain it like this. Neutral. Why neutral, sir? Because that positives and negatives are equally distributed for earth. So while adding or removing, there will be not changes the potential of the earth. So that earth is considered as a zero potential. Not only that, earth is a huge magnet, huge magnetic field is there, because we have a north and south pole. North pole, south pole is there. So that earth also become like a magnet, it behave like a magnetic properties, it possesses the magnetic properties. Not only that, here the charges also we can take like this. Clear? It is for 2 marks related to the electric potential, and here it is like this, we can say statements, and it is the introduction part, and the 2 marks question, define electric potential and define electrical potential difference also sometimes he may ask you. Clear? So this is related to what? About a electric potential. Of course, capacitance is there, that is the next topic. So we'll finish about only potential, then after we'll look into the capacitance. Clear? So this is the information related to the potential. Of course, now you know everyone potential. Potential is nothing but a, once again I'll repeat you, potential is nothing but a work done per unit test charge. Work done per unit test charge, bringing from infinite. It is bringing from infinite into the field. It's nothing but a electric potential. Work done per unit positive test charge is bringing from infinite, and it is placed at a point in the field. It's nothing but a we can call as electric potential. And you remember it is a scalar, and we know dimensional formula and as well as units. And by using this, again we have to derive an expression for electric potential, right? We have to derive like we know electrical field E is equal to 1 by 4 pi epsilon naught q1 q2 by r square, sorry q by r square. Like here force we know that is 1 by 4 pi epsilon naught q1 q2 by r square, that is a Coulomb's inverse square law force, and electrostatic force and electrical field E is equal to 1 by 4 pi epsilon naught q by r square. Like that also we have to derive the potential expression also, right? That we'll see in the next class, and I will continue in the next class. Due to a point charge, again it is also for 4 marks, right? Thank you very much. Thank you. We'll see in the next class.